Hi guys, first video for A-level maths, and you'll probably hear a lot of lawnmowers in the background, dog barking, so I do apologise for that. So what we've done so far in statistics has been fairly straightforward GCSE material, but this is the real new stuff that you won't have seen before. So variance and standard deviation are both new terms. I'll go into a little bit of an explanation as to what it means first. So in this diagram, you can see that we've got a line at 9 because this is where the mean is, okay? And you've probably not seen that notation before either, now I come to think about it. That is X bar, and that stands for the mean, okay? That is a Mars bar. All right, thanks. I know the only person who laughed at that was Matt, so thank you, Matt. Okay, anyway, we have got a line at the mean, and we've got over here our data. So what we're going to do is work out the distance that each of these points is from the mean. So if it's to the left of the mean, you'll see we've got a negative. If it's to the right of the mean, it is positive. Now if we sum that up using our summation notation, the sum of that column there gives you 0, and it will always give you 0. So that's not really very useful to us. But what we can see is by working that out, we can see on average how far each value is away from the mean. So the total distance is 0 because some are over, some are below, and the average is the mean. So you would expect it to be 0. But we're trying to look at how far on average each value is away from the mean, okay? The distance away from it. So just adding it up like that gives you 0. That's not great. So what we can do to get rid of those negatives is to maybe square it instead. So that's what we're going to do. So let's try squaring the data. So we're going to go down this whole column and we're going to square the values instead. And if we square them, obviously we get positive values as you'd expect. And this tells us a little bit more. So if we add all these up, if we add that column and then take the mean of it, that gives us something called the variance. So that is little sigma. Little sigma squared is the variance. And if I square root it, that gives me the standard deviation. So this is the formula for standard deviation. That is the formula for the variance. Now, hi guys, first video for statistics, and you'll probably hear a lot of lawnmowers in the background, dog barking, that kind of thing, kids, etc. I've tried to hide away, but it's not easy when you're isolated in the house. I thought I'd do a video for this because it is new. The stats you've done so far, you're looking at mean, median, that kind of thing. Variance and standard deviation is completely new. Now, it's a measure of spread, and what it does is look at how far on average each value is away from the mean. So you've got some values down here, you've got some values over here. And what you'll notice is when we work out the distance that the mean is away from each value, some are negative, some are positive, and something quite unusual, I guess, happens. Now, if you've not seen X with a little line over it before, we use that for the mean. that is X bar. That's how we say it. So X bar is the mean. That is a Mars bar. Thank you for laughing, Matt. Okay, so this one, 2 take away 9, -7, -4, 0, 3, 8, etc. Now, if we add these up, we get 0, which you probably expected because... Hi guys, first video for the statistics chapter, because we're doing a new topic here, variance and standard deviation, something you've never seen before. I apologise if you hear lawnmowers in the background, kids, etc. I've tried to hide away as best I can. Now, variance and standard deviation are a measure of spread, and they look at how far each value is from the mean. And if you don't already know, that stands for the mean. That's called X bar. This is a Mars bar. Thank you for laughing, Matt. Okay, so each of these values is a certain distance away from the mean. So 2 take away the mean, which is 9 -7 -4, 0, 3, 8. So I've just subtracted the mean from there. If I add all those up, this is capital sigma here, meaning sum up. If I sum up that column, I get 0, which you might have expected because you're working out the average distance from the mean. So it's 0. That's not going to really be much use to us. So what we can do instead is take these values, some of which are negative, and let's square them instead. And when we square them, obviously, we don't get any negative values in here. So this might be more useful to us, okay? So adding that up, you get 0. But by squaring them, it might be more helpful to us. And if I sum up this and divide by n, so I'm summing up that column, and then I'm taking the mean of it. So I'm taking the average of that column. What I get is the formula for variance. So the formula for variance, little sigma squared, is the sum of the squares of the differences and then take the mean of that. So this bit here is the difference between each value and the mean. Square it to get rid of the negative symbol, sum it up and take the mean of it, and that gives you the variance. The standard deviation is simply the square root of that. So those are 2 of your formulae. Now, if you have a particularly large population, you're probably only going to want to take a sample of that. So when you take a sample, it's not a true value. It's only an estimate. So we have something called the sample variance and the sample standard deviation. And we can't use sigma for these because sigma stands for variance and standard deviation. So we use S instead. So S stands for sample. And all we do for that is we divide by n-1 instead to be slightly more accurate with our estimation. So if you divide by n-1 instead, it is because you have a sample. And you might also see the word unbiased estimate. So if the question says, work out an unbiased estimate for the standard deviation of this population, then you are using one of these formulae. Okay, so there's some more formulae. They do exactly the same thing. So variance, standard deviation, these are for samples. Why you would use these ones over the other ones is because they're basically a lot easier to use. With the previous ones, so back here, you'll see that you have to subtract the mean from each value and then square it. So looking back at this table, you have to do all of this. Imagine doing that for 100 columns. It's just ridiculous. So these ones are more calculator friendly, and all you have to do is take each individual value, square it, divide by n, and then subtract the mean squared. So it's a little bit easier to use. So those are much better to use for group data, or if you've got large data sets, as it says up here. Right, you can do all of this on your calculator, and it's not that easy to tell you how to do it. I prefer to show you, but that's not possible right now. So these values need to go in here. Now, I haven't figured out how to do it on a class with, but on the graphical calculator, I'm going to try and talk you through what I'm about to do on mine. So I've turned it on, and I've turned it to stat mode, so the second option, stat mode. And then you have a table of values. So I have gone through, and in list 1, I've typed 18, 6, 14, 2, and 18. And then you get an option saying var, which I have just pressed. So I've pressed calculate, and I've pressed 1 var, and it's worked out for me the standard deviation and the sample standard deviation as well. Okay, so on your calculator it comes up with this little X because that's the data I'm looking at. So I've got 5.89 and 6.58. So if you've done it correct, you should get a whole list of information. You get a list like this on your calculator, so it tells you the mean, it tells you the sum of x, it tells you the sum of x squared, it tells you sigma x, it tells you the sum of x, sorry, the sample standard deviation, and it tells you n as well, how many values you've put in. So that is using the stats mode and filling in your table. What you have to be careful with is here I've only got one column of data. I haven't actually got any frequencies. So there's a button that comes up, says set. When you press set, it asks you what is in your X list and what's in your frequency. So my X list is list 1, and for frequency I have to press 1 because I haven't got a second list. Each value here only occurs once. Let me show you another frequency table where we have to do something slightly different. So here we've got multiple occurrences of each number. So to do this on your calculator, what you have to do is go into stat again, and you fill in list 1 and list 2. So this will be list 1, this will be list 2. You've got a button that says set. Once you press that, you will have to type in, you'll see X list and frequency. Here you want list 1 to be your X's and you want list 2 to be your frequencies. So I've changed this here from 1 to list 2. And then what the calculator does is it picks up whatever's in your first column as your X values, and then whatever's in your second list as your frequencies. And then I've gone to calculate 1 var again. So we're only dealing with one variable at the moment. There's only X's in there, there's no Y's. So 1 var So that is in the corner of my screen. That's what I'm clicking, 1var, and I get a whole list of data. It says that sigma x is 0.97 and my sample standard deviation is also 0.97, so they're very close. Okay, now if I was trying to do this by hand, the formula would be slightly different. So because I've got F involved here as well, my sigma would be either this, and you are given a lot of these in the formula booklet. You won't be given them all, but you will be given enough to use if you do forget. This one's by far the easiest one, the one I'm writing now. I've never actually used that one before in my life. So this one down here, you're doing your x squared times by your f, adding all of that up and dividing by the sum of f. Take away your mean squared. So it's the same kind of idea, but just with an f in here instead. And if you wanted to work out the variances, it would just be, so your sigma squared and your sigma squared here would be the same formula, but without this square root here. Okay, so it'd be the same formula over here. Right, I hope that helps a little bit. I know it's not ideal, but I hope if you have a read through the examples and this video as well will then help you to have a go at some of the questions I've set on the chapter checklist. Okay, best of luck. I hope you're keeping well, and I hope to see you all again soon. Bye.